And one of the things that I really am passionate about is showing the kids the application of algebra in real world situations. And so what I use is my physics and chemistry labs and activities to show them where it involves things like motion and velocity and acceleration, or maybe we're doing one where we're doing forces and Newton's laws, or maybe we're talking about light or sound, all the things that the kids can relate to in real life. And so what I did for this activity is I had buggies, and the kids had to find the velocity and the acceleration of it. And then for this second activity, we did Hot Wheels cars going down a ramp, and again did velocity and acceleration. And so then what they did is they did a comparison between the two types of graphs and looked at what the graphs looked like when it was constant motion against what the graphs looked like when it was accelerated motion. And we talked about a lot of different mathematical concepts. And so I'm going to take a minute and show you the one of the PowerPoint presentations that the kids had to do and some of the things that they collected. Okay, so one of the first things that the kids had to do with their buggies is set out a track on the ground and record the time that it took for the buggies to go, as you can see, from 1 meter to 8 meters. And what we do with every activity is we always do 3 trials, so they're always having to do the average of their data. So once they get their data, then we take it and we put it into a distance time graph. And so again, for this one, it was a battery operated car. And so as you can see from their data that they posted, that it's a very consistent graph and a consistent slope for the most part on here. And so we were able to talk about that constant velocity on the car is the same as a line which has a constant slope. And then of course we related the slope to distance over time, which is just like your change in y over change in x, which is your velocity. The other thing that the kids did was they took 2 of the cars and shared their data, and then we had to do a comparison to see which one was going faster, which was going slower. And then they were given the situation where if the cars were 12 meters apart, then how long would it take for the 2 before they hit? And so we've taken our information and we've made it into a system of equations that they have to write an equation for and then graph. And I did require them to do both, write an equation and graph, even though the equation is not shown here. So we've got several different graphs. This was the blue number 2 and blue number 6. This was blue 6 and green, and you can start seeing that their velocities are a little bit different there. And then this is blue 2 and green. Okay, so for the second thing that we had to do is also a velocity time graph. And so this again is for the buggies. And what you can see here again is just an affirmation that it was a constant velocity, and because the slope of our velocity time graph or acceleration is a horizontal line. And so then that kind of goes back in and just kind of reiterates the fact that the slope of a horizontal line is 0. Okay, and then the second piece that we did was going down the ramp. And the data there doesn't ever come out quite as nice. So we do talk about things that we could have done better in order to make our data look better. And one of the things that we have found is that if we video in slow-mo on that, then we can get a lot better accurate readings. And so that is one of the advantages of having the graphing, or I'm sorry, of the iPhone or any phone and having the slow-mo on there, is that it works awesome for your labs to be able to collect data. Now also what I didn't talk about, but an extension to this that we use a lot in labs, is the Vernier software and the CVLs or LabQuest or so forth. And so if you have access to any of that, that's always a great addition to your class. The other thing I haven't mentioned, but all of our graphs here were done on the Desmos app. So again, the integration of the technology. And so you can put in as much or as little integration, because you can go all the way down to lower grades with this, maybe not the ramp and so forth, that might be a little hard for them, but definitely a buggy on a flat surface and having them do some timing, they could handle that. And you could even plot it just on a regular graph. You would not have to use any of the apps or anything. Okay, I want to show you a little bit about what the kids did.
Shapes Advanced Algebra class. I'm going to be talking about a buggy lab that we did earlier this year. We set up two different situations with these buggies, one where the buggies were going in the same direction and one where they were going in opposite directions towards each other. We found things like velocity and the curvature of the buggy to determine when the two buggies would collide. After we calculated and got the numbers, we used a slow motion video to time when they would actually collide. I think this lab was important to us because it showed us that advanced algebra is used in the real world, and our cars is one of the best examples of advanced algebra being used in the real world.
Okay. Go.
Two activities in class. One activity was where we put a car on a ramp at different heights and measured how long it would take for the car to get down the ramp. The other activity was where we put multiple mechanical buggies on the floor and recorded how long it would take for the mechanical buggies to get to different spots on the floor. These were important in our algebra use because we were able to figure out the velocity of the car going down the ramp, and that the pull of gravity was what was affecting the acceleration of the car.
That was good. Told you we were faster.
The different ways that we integrate. Well, I hope with this lab you've been able to see some of the ways that you can integrate your physics and or your chemistry into your math courses and let the kids have some hands-on experience so they can really see where we really use algebra in everyday life. So I hope you enjoyed this.